Alright, so in today's video, I want to go over how to graph polynomials by hand without using any graphing technology. So let's look at this first question right here. Here they give us a polynomial, a function. This is already in factored form. So that will help out a lot when we find the zeros, which is very important in this problem. But most important thing, just a reminder, we talked about the end behavior chart. This is something that I will be referring throughout the video. And we also talked about the multiplicity of a zero and looked at the behavior of what occurs at that zero based on its multiplicity. So I'll also be referring to that as well. But here, once again, they give you a polynomial function in factored form, and they want you to graph it by hand. So here's what I always recommend for these types of problems. We first want to think about the end behavior of this polynomial that they give us. When we think about end behavior, you want to think about the dominant term of the polynomial. The only issue is that when we look at the function they give us, it is in factored form. So the way we find our dominant term is to take each piece one by one. So if you look at this first piece right here, x plus 1 squared, the dominant term within the parentheses is going to be x, but all of that is squared. So my dominant term for this first piece is going to be x squared. And then I'm going to multiply that by, let's look at the other piece. The dominant term here is 2x. We have an exponent of 1, so we're good. So the dominant term within here is 2x. So I'm going to multiply the x squared by 2x. And then we're going to multiply that by the dominant term within this set of parentheses, which is just x. There's no exponent here, so we're good. So the dominant term there is x. Using the laws of exponents, we just simplify what we have here. This will ultimately give us 2. We have 2x's here, another set of 2 here. So 2x to the 4th power after we multiply that out. Notice here, if you look at the exponent, we have an even degree polynomial with a positive leading coefficient. So looking back at our end behavior chart, for an even degree polynomial with a positive leading coefficient, well, we're going to be in this region right here. Both arrows are going to be going up. The ends are going to be pointing up. So on the graph here, we know that at some point the graph has to be going up in both ends. So that covers the end behavior portion of the graph. Now the next thing I always recommend is to locate the zeros of the graph. Once again, these are the x-intercepts. And what's really nice about this is that, once again, they give it to you in factored form. So the idea is we want to set our f of x equal to 0. Once again, we have zeros when our y value is equal to 0. So that's why I set this equal to 0. And then now we're going to set each piece we have here equal to 0. So I'm going to set x plus 1 squared equal to 0. I'm also going to set 2x minus 6 equal to 0. I'm also going to set x minus 5 equal to 0. Once you set each piece equal to 0, we then solve each piece for x. Once again, you can think about the trick we mentioned back in class. Here, if you solve this out for x, it'd just be the opposite sign on the inside. So here, if we take the opposite sign of the inside, we have x equals -1. That's the first 0. Here, be real careful with these. You do have a coefficient in front of x. But here, don't forget, we add 6 to both sides. And then we divide by 2. We get x equals 3. That's our other 0. And then this, we'll just take the opposite sign. So x equals 5. So our zeros, our x-intercepts, are located at x equals -1, 3, and 5. We can mark that here on this graph. So at -1, we have a 0. We have a 3, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, At 3, we have a 0. And then at 5, we have a 0. Okay. So we talked about end behavior. We've located the zeros of this polynomial. Now, next thing that I always recommend is to analyze the zeros that we have based on their multiplicity. So here we're looking at the multiplicity of our zeros. If you look at x equals -1, I'll write that here. We had a multiplicity of 2. So I'll abbreviate that as mult2 because of our exponent. If we look back at the multiplicity chart we had looked at in class, the multiplicity here is even. If you have an even multiplicity, the behavior at the 0 is that the graph will bounce off at that 0. So here at -1, we're going to be bouncing off. Another word to describe that is tangent. The same for our next 0, x equals 3. This term, 2x minus 6, only came out once. We have an exponent of 1 technically there. So its multiplicity here would be 1. If you have a multiplicity of 1, which is odd, we said that will cross the cross the x-axis. It'll intersect at that 0. So here it crosses, we'll call that intersects. And for the last 0, x equals +5. That is going to have a multiplicity, if we go back up, of 1. That term only comes out once. Once again, you have an exponent of 1 there. So here we have a multiplicity of 1 for that 0. This is an odd multiplicity. If we have an odd multiplicity, our graph will be crossing at that 0. It'll intersect at that 0. So it crosses or intersects. Okay. All right. So we mentioned end behavior. We mentioned locating the zeros. We mentioned the multiplicity of the zeros and their behavior of what should occur. There is one more attribute I want to talk about, which is the y-intercept. Before I talk about that, though, let's look at the graph up here. And let's start sketching it a little bit before we talk about the y-intercept. So here, I'd always recommend starting from the left-hand side. So here we know that we have to be going down. We have to be approaching our 0 of -1. So I'm going to approach it, I'm approaching it. And then at -1, we got to understand what happens here based on the multiplicity we said earlier. So at -1, we said that based on this multiplicity, we're going to be bouncing off the x-axis. So we're going to bounce off that 0. So when I approach -1, I'm not going to intersect. I'm not going to do that. I'm going to make sure I bounce off at -1. So I bounce off. And then here's where you got to be just a little bit more careful. They mentioned the y-intercept in this problem. That's useful information we can use to have an idea of where this graph will cross the y-axis. So when we're dealing with a sketch here, you can go just a little further and find the y-intercept. And once again, the function they give us in this problem, I'm going to rewrite it. This is the function they gave us. To find the y-intercept, we're going to plug in x equals 0 into our function. So I'm going to plug in 0 in for x. Wherever I see an x, I plug in a 0. So I have 0 plus 1 squared times 2 times 0 minus 6 times 0 minus 5. We simplify this. 0 plus 1 will give us 1. We have 1 squared. 2 times 0 is 0. 0 minus 6 will give us -6. And then here 0 minus 5 will give us -5. We simplify this a little more. 1 times 1, that'll give us 1. 1 times -6 will give us -6. And then if we just multiply that out, a negative times a negative will give us a positive number. 6 times 5 will give us 30. So our y-intercept will be located at 0, because remember we plugged in x equals 0, comma 30. All right, so that's something I could plot up here. So when I go into the graph, we know that it has to hit at 0, 30. So I'll just go up a little bit, up a little bit, up a little bit, up a little bit. And then I know at some point I have to be coming back to 3. I have to be approaching the 3. So now when I approach the 3, at 3, based on the multiplicity, at x equals 3, we know we have to cross the x-axis. It'll intersect at that 0. So I'm going to cross it. And then here, how about us in saying, how low do I go here? Once again, this is just a sketch. You can go as low as you want, but as long as you make it a good approximation, you're good. So we know it has to go just a little low, but then at the end of the day, it has to be coming back up and approach the next 0, which is 5. And then once again, at x equals 5, we have to cross the x-axis. So here we'll go down a little bit. Now we're going up. At 5, we're crossing it. And then now we follow the end behavior on the right side. Okay. All right. So that is the idea behind sketching a polynomial by hand. Once again, the rest of these problems, question 2, 3, and 4, are for extra credit plus 5. If you are going to complete this, make sure to show all this work right here. Once again, you want to graph this by hand without using any graphing technology. Notice I didn't use any Desmos. You can use a calculator for calculations involving the y-intercept. That is acceptable, but no graphing technology here. Okay. And final thing I enough in the video is, let's just say I graph this on Desmos. This is double check our work. Let's see how accurate this picture is. If I go on Desmos and I type that in, okay. The graph will look a little weird. What I'd recommend is scaling the y-axis just a little bit, and then you'll see that this graph kind of does look like the sketch we have in our worksheet. So here it crosses at -1, crosses at 3, crosses at 5. We have the y-intercept of 0, 30. The ends are both going up. It bounces at -1, crosses at 3 and at 5. So this sketch we made is a pretty good sketch. All right. If you have any questions about these, please let me know. You will definitely see this next year if you take pre-calculus. As always, I'm more than happy to help out, and I hope you have a great day.